So now let's get started. So today we have a very exciting topic, streaming Iceberg, right? How to do it, right? We have a very special guest, Yingjun Wu from RisingWave. Yingjun, do you want to do a introduction yourself?
Sure,
Introduce
sure,
yourself.
sure. Yeah. First of all, thanks for having me here. And I'm Yingjun Wu. I'm not sure whether you. So yeah, I think you guys have already had the marketing classes out. So probably basically I'm currently running a company called RisingWave, which is a data streaming company, and our focus is about stream processing, streaming analytics, streaming management. And RisingWave is open source distributed SQL streaming database, and which is offering the best-in-class stream processing experiences. And super happy to be here.
Yeah. Thank you, Yingjun. Now let's get started. I forgot to introduce myself. I'm Cedar Shen, product manager at Seller Data. We do query engine on top of Apache Iceberg. So now let's get started. So to kick everybody off, what is Apache Iceberg and why should we be excited for this project? Yingjun.
Iceberg is the open data format, right? Actually, I feel that for last year, I actually still have to educate people about what Iceberg is, but this year it's like, everyone is adopting Iceberg, and it's open data format. Basically, if you store data in, let's say, Snowflake or probably Redshift, so forgot to introduce myself. Mention this in my intro. I actually worked for Redshift before starting the company 4 years ago, almost 5 years ago. And one was in Redshift where everyone was talking about, let's just store everything in Redshift, right? But the problem here, that's why if you store data in, let's say, Redshift or store in Snowflake or probably BigQuery, right? Essentially, the problem here, that's where you are actually storing data in their data format. So if you want to use some other tools like DuckDB, right, or probably StarRocks or probably, Trino to query your data, there's no way. Because they do not really know their data format. So you basically have to copy the data out, right? That's the only way. So that's why we actually have the project called Apache Iceberg, which was first introduced by in Netflix. And the main idea is that instead of just storing data in proprietary format, we can just storing one data format, that is PQUery, right? Everyone can recognize what PQUery is, right? And but what the issue with PQUery is that's why it's just a data format. But if we want to read the table, we actually have to have an abstraction layer on top of our PQUery files, right? And that is Iceberg. So Iceberg is not an open data format; it's the open table format. And with this table format, you can use any tools, no matter whether Spark, RisingWave, StarRocks, DuckDB, or even Snowflake database. You can use all these systems to read the data and write data. Yeah,
that is great.
To choose.
Yes, storing everything that other tools can use, right? That's the only way you take ownership of your own data, right? If you're storing your data in a proprietary format that can only be used by one system, that's not your data. That's that system's data, right?
That
makes sense.
That will make things very complicated. For example, if you let's say for PII, right, for all kinds of reasons, GDPR, whatever reasons, you actually probably want to update some data, probably remove some data.
Yeah.
If you store data in, let's say, 10 different data systems, right?
Yeah.
Then you actually have to trigger deleting every single database system.
Yeah.
But if you store in Iceberg, it's like, just remove the data there, and everyone can get access to the data.
Yeah, it really simplifies data governance, right? Because it's only like a single source of truth there, right? You have to worry about, right? So that's Apache Iceberg. Thank you for the introduction. And the second part of the title, how do you define streaming? What is streaming?
Oh, streaming. I think So whenever we talk about streaming, people were thinking about, let's say, Kafka, right? Because Kafka is, I know that's for most of the companies where they use Kafka, but Kafka is more about basically the buffer or a messaging queue or temporal storage for storing or buffering the streaming data. And what the streaming data is, let's say IoT data, right, from your sensors, or trading data from your, let's say, stock market, right, or live market data or order data, right? Well, if you're running, let's say, e-commerce or logistics company, then you also have the order data, right? Order data is also like a streaming data because, right, because we actually have a lot of orders, right, coming in every single day. So those are all streaming data. And even for the, I mean, if you're not running this kind of company, if you're just let's say, running a website, in your website, you actually also have the, let's say, so-called user behavior data, right? So you actually have really want to collect their data. Think about the Google Analytics, right? They actually have to collect all this kind of user behavior data, like which page you access, right? And how long you spend on every single page. These are all streaming data. But for Kafka, people really love Kafka, and we also love Kafka. But Kafka is like as you just mentioned, it's a messaging queue. It's a buffer, and it's the temporal storage for temporarily buffer the streaming data, right? And that's data streaming system. But for in RisingWave's case, we talk more about streaming processing.
Yeah.
The difference between stream processing, data streaming, and the stream processing is that it's more about the storage versus compute, right? And so RisingWave focus on computation, while Kafka focus on storage. But we actually also offer storage, which is
so streaming with the state, right? Streaming with the state, and with processing.
Like for the thing here, that's so we can definitely talk more about how we process the data, right? Let's assume that's if you just want to do something like simple manipulations, like filtering, whatever, right? And you do not really have a lot of data, like every single every single hour you just have one event. Then you actually probably can just write a Python, right, or a Python script to process the data. But think about and you probably can just store everything in, let's say, something like, you probably do not need Kafka. You probably just need, let's say, something like DuckDB, right, or in-memory database, probably SQLite, right? And but the problem here, that's if you have a lot of data, let's say every single second you gather, let's say 1,000 events, 10,000 events, 100,000 events, or 1 million events. In these cases, you actually have to find some systems to to continuously process the data, right? But even if it's just like a simple filtering, right? Well, you actually have to find some systems that can continuously process the data, do transformations, do analytics, do joins, aggregations, time window functions. Then in this case, you actually have to use some systems, right? And the RisingWave is such kind of system.
Yeah, it sounds like a lot of real time, a lot of incremental compute, right? Processing a whole bunch of data, but only process the incremental ones, right? So you get, good data freshness and everything's in real time, right? That's why I'm curious. Apache Iceberg was born in the batch world, right? Was born in data lake, or to replace, Hive, Apache Hive's pain point. Yeah, solve those pain points. But why are more teams are now building their streaming pipelines on top of Apache Iceberg?
Well, so if you look at the big data history, right, when Iceberg was invented, I think it was around 2015, I think, 2015 or 2016. And at that time, people were just running Hadoop, right? They were still figuring out, how we can run Hadoop, right? And then people think that, Hive, we probably need a layer on top of Hadoop, HDFS, that is Hive. But they feel that's where there are a lot of pain points in Hive, right? So schema evolution, whatever, right? So they actually brought in Iceberg. So they invented Iceberg. But at the same time, at that time, at that time, most of the data are statical data, right? We probably don't need to have something like, it's kind of still early stage for the streaming data, right? But because if you think about Kafka was invented in around 2010, right? At the time, only companies like Google, Facebook, Microsoft, they could process streaming data, right? Well, to be honest, one fun fact is that's why I used to did my intern in Microsoft research, and what they did was that was around 15 years ago. And what they were doing was like, okay, they had their in-house stream processing system processing the streaming data, like from the Bing, Bing, right? The search engine from Bing, and using 400 machines. That was 10, 15 years ago.
Yeah.
But nowadays, everyone is using Kafka, right? So you can think that, okay, in the bash world, people are moving from Hadoop to HDFS to Hive to Iceberg. While in streaming world, people move from not just the Big 10, right? Well, big techs can run streaming data, right? Applications, but all these like SMBs, mid market, where they can all running small applications, data streaming applications. So naturally, people started thinking about, okay, whether we can ingest a stream data into some data systems that can persist my data, right? And we don't really want to store data in some very expensive systems like BigQuery or probably Snowflake, right? So we actually want to store data, persist my streaming data in open table format, or in somewhere that is open, right? So that's why people start thinking about, okay, whether we can ingest data from streaming data into Iceberg. Yeah, that's the history.
Yeah, so you can do real time, you can do streaming, without breaking, the data governance, and without like creating 15 different small systems you have to worry about later, right?
Yeah, definitely.
Yeah, that makes sense.
People really hate to do that.
Yeah, so that sounds really interesting. Can you share a few like real world use cases where streaming Iceberg pipelines has been impactful for businesses?
Oh well, I think that the mostly, I mean, if you consider the like data streaming plus Iceberg, okay, and also specifically RisingWave plus Iceberg, and even and also plus StarRocks. I think the most successful use case we have is in the world's one of the world's largest company running the. I mean, I could not name the company, but essentially they are a $1 trillion company. They actually running a recommendation system. And in every recommendation system, what they want to do is that they actually collect user behavior data from somewhere, right? Was the application, collect the user behavior data, do transformation, and then log the transformation. There are two pipelines. One pipeline is actually to generate signals, right? Well, probably it's not actually not called signal, but to generate to deliver and transform the data back to Kafka. And the other way is to lock down the results into Iceberg. Mm-hmm. That's pretty realistic, right? Because this is a $1 trillion company, and they actually need to process huge amount of data.
Yeah.
If they store everything in some database like I don't know, BigQuery, or they could not use BigQuery, sorry. Snowflake, it would definitely break the bank, right? Because it's too expensive.
Yeah. It's too expensive.
They also don't really want to be vendor lock-in, right? Where they don't really want to pay hundreds of millions of dollars. I'm not kidding. Hundreds of millions of dollars to certain vendor. They do not really want to do that. So they actually have to store some data in open data format. That's pretty realistic, right? And that's the $1 trillion company. I know that's what they're probably just 3 or 5 $1 trillion companies, but if you think about all the other companies, right? Well, enterprises, mid markets, well, as long as we have a high velocity data, they have, let's say, they care about the openness, they care about the data quality, they care about the cost. They would definitely think about moving away from some proprietary data format to some open data format.
Yeah, that makes a lot of sense. So it looks like a lot of the big players in the market are already moving their streaming architecture to open formats, to Apache Iceberg, right? What do you think are some of the challenges of running streaming pipeline, or building streaming pipeline, or running those like real-time applications on top of Apache Iceberg? What are some of the challenges?
I think that's definitely a big topic. I probably can spend another an hour to discuss every single challenges. But look, what the thing here, that's what people think about. People tell me, okay, so we have Kafka, and I'll probably have Postgres, right? Or I'll probably MySQL, right? And I want to dump the data into, let's say, ingest the data into Iceberg. Let's just use and they will imagine that, okay, there are some API, right, inserting into.
Yeah.
Let's just do inserting into Iceberg. But unfortunately, you could not do that. For first of all, I mean the Apache Iceberg. I mean, first of all, you actually have to have some system to handle the insertion, right?
Yeah.
And the second thing here, that's for the, I mean, there are a lot of like handling insertion is just too simple, right? But the main challenge is about, well, okay, you actually have all these challenges listed here. So schema evolution, small file accumulation, primary keys, batch commit, or whatever. So we can discuss one by one. Okay.
Yeah.
I think the first thing is that we're different from the batch data. Streaming data is continuous, right? Every single second you got, let's say 100 is actually 100 events per second is actually pretty small, to be honest.
Yeah.
Let's say 1,000 events, right?
Yeah.
10,000 events, 100,000 events, a million events ingesting came in, right, from your website, from your IoT sensors, from your if you're doing crypto, right, well, definitely a lot of data coming from the blockchain. Yeah. So essentially, the problem here, that's if you just insert everything directly into Iceberg, assuming that you have something like, I don't know what kind of system you have, but well, assuming that's where you have a magic system that do insertion into Iceberg, I definitely the first question you will find is that, well, you could not, it will crash immediately. Why? The reason here that is under the hood, under Apache Iceberg, it is essentially Paquet.
Yes.
If you understand Paquet, it's essentially a column store, right? So it's actually called a packs, right? It's actually basically a column store, and continuously inserting into a column store is always a pain, right? You cannot do that. So what's the solution here? The solution here is that you actually have to buffer the data in some your some kind of system, right? Where in RisingWave cases, you can buffer the data in RisingWave.
Yeah.
And to accumulate data there for, let's say, a second, or probably 10 seconds, totally depends on the data volume, right?
Yeah.
And batch commit into Iceberg. So you could definitely mitigate this the inserting problem, right?
Yeah. It's really, I think it's a trade-off between, like how much freshness you want and how much you don't want your system to break, right? Yeah, so either you have fresh, you have really fresh data, or or you have larger files, right? And that is basically a trade-off right here.
Yeah, definitely. There are actually more trade-offs, right? And also, you also need to consider how much data you have, right? For, let's say, the data volumes, right, or the data velocity. I mean, writing 1,000 events per second is totally different from writing, let's say, 1 million events per second.
Yeah.
You actually have to also have, if it's like 10 million, 1 billion events. 1 billion events is probably too much. But well, let's assuming that we have 10 million events coming in every single second. You actually could not just probably use one single CPU, right? So we could definitely not do that. So we actually have to probably use distributed systems. And RisingWave itself is a distributed system. But basically, again, you actually have to consider how much events you have, and how many events you have will determine how many CPUs or how many machines you need to have, right? And then, as I just mentioned, you actually have to buffer the data into temporarily in some system in RisingWave, because we're discussing about RisingWave. So buffer the data in RisingWave and batch commit into your Iceberg. And the commit ratio could be like every single second, every 10 seconds. And typically we see, totally depends on your use case, right? Well, I mean, we sometimes we see 5 seconds, 10 seconds, I think
Yeah.
that's definitely reasonable. And what 10 seconds means that's okay. RisingWave buffer the 10 second, the data for 10 seconds and write into and batch write into Iceberg. So that's what the freshness will be like a 10 seconds.
Yeah.
10 seconds is actually good enough for many use cases. 5 seconds, probably even better, right? So you could probably do something like a fraud detection. 1 second is definitely, fraud detection, definitely works.
Yeah, that on top of Apache Iceberg. Does that have like deletes have anything to do with that as well? If you have deletes, you probably shouldn't ingest that frequently for Iceberg.
If you have a lot of deletes, well, actually, that's another topic. Okay, so yes, yeah, so okay, so I can let me mention it later. Okay, so let's focus on a small file problem, right? So but what the problem here, the thing here, that's what you actually. So some people will say that okay, we can buffer the events in RisingWave and let's say do commit every single second or probably every 10 seconds. But the other problem here, that's what it doesn't really solve the problem. That's why you still could probably have small files.
Yes.
Why? Well, why you can't have small files even if you do batch commit? The reason here that's why you could not guarantee that you always have, let's say, 1 million events every single second, right? Sometimes you probably just get let's say 1,000 events, and sometimes you get 10,000 events. And so I mean, you flush the data into Iceberg, everything every single, let's say 10 seconds. So there'll be some bigger files and some small files, right? If you have a lot of small files, the challenge here that so it's actually not very good for your query engine, right? Think about it.
Yeah, it's really bad for us. Yeah, it's really bad for us. I mean, scanning a gigabyte, Parquet file is way better than doing 1 megabyte ones.
Yeah. So look, well, I mean, for StarRocks, I know that you are pretty good at doing doing the lake analytics, right? Yeah. The good thing here that's StarRocks can help you to do a lot of like magic things, right? I know that's why I did some research, like a parallel loading let's say the metadata, right? Well, probably doing some caching. I know that's where you can do caching. But you definitely prefer bigger files instead of
those are workarounds. Yeah, those are workarounds. I mean, S3
definitely there are workarounds. But
S3 is just too slow, to even on the SSD storage, that many scans, right? Sending that many scans even to SSD is too expensive for like low latency kind of workload. So definitely small files, that's small Parquet files and small metadata files, right? And those, all cause a lot of problems. And small files creates a lot of metadata files, and that's even more harmful, for query planning. So yeah, that definitely is a pain point that we see.
Yeah, definitely. So so essentially, as to summarize, right? I think we have already spent a lot of time working on this topic. So to summarize, well, I mean, so first of all, you could not continuously insert the data directly write the data into Iceberg every time a new event comes in, right? So it's not possible. And so to handle the problem, you actually have to use two mechanisms. The first one is to buffer. The buffer, let's say, buffer the data inside of like a RisingWave, right? And then you could probably do the batch commit into Iceberg every single, let's say, second, or every single 5 seconds, or probably every single every 10 seconds. Totally depends on your application. And second thing here that we need to consider is that even if you do the batch, you probably still have a lot of small files. Small file is typically not very good at for query engines, right? So it's not very good for query engines. And actually, also the other thing here, that's if you have a lot of small files, let's say 1,000 small files, actually AWS actually charge you based on the S3 access, right?
Yeah,
it could be super expensive. Even if, let's say, StarRocks could be super fast, you actually have to pay AWS money because AWS actually makes money from there. So that's definitely very challenging. So what do we do is actually we actually help people to directly do the compaction. Yeah. So that.
compaction is an interesting topic because I
Yeah,
think
that's definitely a big topic.
Apache Iceberg is just a format, right? It's great, but it doesn't really do anything. Data comes in, it stays there, it doesn't move by itself, right? So
Yeah,
you
yeah, yeah.
have to
Look,
have
I
some
mean,
mechanism to to merge those small files.
so definitely, totally. Look, what the in many cases, people tell me that, well, okay, can I move my data from Snowflake to Iceberg? And what they mean is that, well, can we just have let's say manage the experience of that Snowflake offering, right? But unfortunately, Iceberg itself doesn't really have such kind of like management experience, because well, it's more like I would call it like a standard or abstraction.
Yeah, it's a spec.
Oh, yeah.
Yeah,
Okay, spec,
it's
yeah,
a
yeah,
spec. That's all it is.
yeah. It
It's
is a
great
spec.
though. Yeah.
And it's basically a standard, right? Everyone agrees on, right? So it's like a Postgres protocol, right? So you can, I mean, RisingWave is Postgres compatible, but it doesn't really mean that we actually borrow the code from Postgres. It doesn't really mean that. It just means that everyone follows the standard. So, and to follow a standard, you actually have to implement everything on your own. Let's say doing compaction, right? Iceberg, if you have a lot of like small Parquet files, right? Iceberg will not help you to compact the Parquet file directly.
Yeah, compaction is normal
You
in
have to
any
handle it on
database
your
system,
own.
but
Yeah. So how
yeah,
to do that? Yeah, definitely. The next question will be like how to do that, right?
yeah,
So people, I think in AWS where you can use EMR, serverless EMR, or probably you have dedicated EMR for sure. You can do that.
yeah,
Basically to use Spark, right, to do the compaction. And the other thing you can do that's what in AWS there's a what is it called? Well, the glue auto optimization, right?
yeah,
Yeah, I forgot the product name, but I think it's called a glue automation. So basically, it's like it's basically a managed Spark experience just for
yeah,
Iceberg. And third option is that we could probably use just manage a service like the S3 tables, right?
yeah,
Yeah, RisingWave is compatible with S3 tables, and I believe that's what StarRocks also compatible with S3 tables. S3 table is just like a managed Iceberg, but definitely Iceberg managed Iceberg table also have some limitations. For example, it's 15% more expensive compared to S3, and 15% more expensive compared to S3. And you also need to pay for the compaction.
yeah,
So 15% is just a basic. Above that, above the 15%, you still have to pay for the ingestion, pay for the compaction.
yeah.
And to sum everything up, well, it could be like 50, right? Well, not 15, it could be 50. So
Yeah, a lot of
yeah.
I think that's why a lot of the users, they turn to DIY, right? To do it themselves. So what are some of the challenges? I just start a Spark cluster, right, and do a compaction. What's wrong with that?
Uh,
Open source. Go
uh,
open source and manage your own infrastructure.
so look,
What
well,
are
I
some of
mean,
the challenges there?
so
Yeah.
look, what Spark is more like an execution engine, right? So, yeah, I know that's what I mean. It's you could use all these kind of like different execution engines to do a compaction, right? So like even you can actually use DuckDB to do compaction. I think I know
Yes.
that's what someone is working on that, but well, I mean,
Yeah.
but well, basically it's more like a compaction. But the challenge here, that's why it's not about the execution. It's more about the strategy. Let's
Hmm.
say what kind of files you really want to compact, right? Let's say that's where you have let's say 10 different files, right? And some files are big, and while some files are small. Which file you really want to compact,
Yeah.
and when you really want to compact, right? And for example, you probably don't really want to compact every single 30 seconds, right? Well, probably too much, right? It doesn't really make too much sense. Totally.
Yeah.
I mean, totally depends on your use case, I have to say. And we could also talk about the delete, right? Some cases where there are a lot of delays, and when do you want to compact, right? So it's more about the strategy it's not about the execution, right? Well, I think the pain point is not, it's not about, okay, whether I should use Spark or let's say Databricks Spark or probably the EMR Spark or probably just use StackDB or embedded Spark to the compaction. It's more about the strategy, when you should do a compaction and how you do a compaction, right? When, yeah, basically what files should be compacted, right?
Yeah,
So,
yeah, I think I think a lot of it is about the strategy. A lot of it is about, do you have the right metrics, to track, do you have the right kind of intel, right? To know like which iceberg tables to do compaction on, right? I think now is the time to now is the perfect opportunity to talk about Nimtable. So can you give a short introduction of? We can
yeah,
go back
actually,
to the reference architecture later after the demo, I
for
think.
sure, yeah, for sure, yeah.
Yeah.
So, yeah, essentially, I saw some people mentioned. I found that there are a couple of questions we haven't answered, but
Yeah.
yeah, someone mentioned Nimtable as well. It's actually a very interesting product. It's an unreleased product we built in RisingWave, and you could actually consider. I actually do have a demo. So know
Yeah.
that it's still unreleased, but we probably will release the official announcement probably later this month. But essentially, what you can see here, that's why it's like a Docker. Everyone can. So if you, so the easiest way. So first of all, the easiest way to access Nimtable is to just go to our GitHub repo, right? So everything is open source. So yeah, it's like so the architecture wise, well, what is Nimtable? The first question is what is Nimtable? Nimtable is the compute plane for Iceberg, but another way to describe it, that's why I would like to call it, because everyone is talking about AI, right? So I could also like to call it like a copilot for your Iceberg, right? But never mind. So I mean, you have Iceberg and you have, let's say, catalogs, you have Paquet files, and you also have, let's say, the ingestion engines and query engines, right? Yeah, that's awesome. You have everything. But the problem here is more about what I should do with a Nimtable, right? Sorry, Iceberg, right? There's no observability tool in the Iceberg world, right? What kind of files I should compact, and which file is the biggest one, and which file I just edited last time, right? Nobody knows. And if you use, let's say, something like manage a system like S3 tables, well, they will charge you whatever they want, and you have no idea what's going on there. That's why we found what we found a pain point, and that's why we built a project called Nimtable. Nimtable is more like a visualization tool, and so yeah, this is a demo, right? Well, so this is a real catalog, okay? S3
Can
table.
you are you sharing your screen? I don't see your screen here.
I think so.
Okay, now we do.
Okay, yeah, it's kind of slow. It's not because
yeah.
Nimtable is slow. I mean, so yeah. So the thing here, that's what this is the real S3 table, right? So you can just create a whatever. Yeah, you can just connect to whatever catalog you have, right? So let's say a REST catalog, JDBC catalog, S3 tables, Glue, whatever, right? And then after connection, I've already done the connection, right? So I don't really want to show my credentials here. So I've already connected my S3 table. So inside that, where you can see something like, okay, I have a lot of like, namespace, 4 namespaces, right? And let's just randomly pick one. Okay, here, this one, we have 13 tables, right? Let's collect. And you can see here that, okay, this one, okay, for all these tables, right, I get, let's say, 1 file, right? Which is good, which is 6 files, not bad. Okay, and this one here, 15 files. Let's go, let's dive a bit deeper into it. And it'll show you, okay, there are 15 files of the size of from 0 to less than 8 megabyte, right? It's not very good for query engines like StarRocks, right? Or yeah. So what you do? You should actually do the compaction, right? So essentially, in the Nimtable, you can actually do the optimization, optimize. Yeah. So you can see that. So okay, when you want to do the snapshot retention compaction, right? And here I just click run compaction, and it will do the compaction on its own. And so people will say that, well, okay, is it like I don't really want to wait, so just cancel it. Yeah, so basically all these kind of things can help you to visualize. Okay, it has already completed. Can help you to visualize your dash. What is called for the iceberg, right? And it also have the so-called this is a cool AI feature, I have to say. Yeah, it's actually connected to OpenAI, and it will generate a table summary. So, and you also can have the data preview, right? And okay, so the data looks like this, right? And also version control. So yeah, this is a pretty quick demo of Nimtable. Yeah.
Yeah, so I have a few questions.
Sure.
That's really cool. You can just take a look at a Parquet file. Actually, just taking a look at what's inside of a Parquet file is not as easy as I would thought. It's actually a pretty challenging thing. So being able to do that is great. And also, what kind of metrics is Nimtable tracking to determine which table needs a optimization?
Definitely, that's a very interesting question. First one is that's definitely number of files, right? Let's say that so you have if you have okay, so yeah, you see that so I just did a compaction, right? So the table, yeah, which table was that? Well, yeah, probably this table, right? Well, it has already been compacted. So I feel yeah, definitely we will track the number of files, right? For let's say that's for the number of files and also the size of the files, right? Let's say that for every single file is like 64 megabytes. Then I think it's kind of like healthy, because for 64 megabyte is kind of like good enough, right? For a lot of current, it totally depends on use case. And yeah, definitely that's something we really want to track. And we also want to track here. We actually have the position delete and the equal delete, right? That's something we probably can mention if people curious about the deletions. We can definitely discuss that later. Okay, we also definitely care about the deletion, right? Because what deletion is typically considered as harmful to Iceberg. Iceberg is not very good at handling deletion, right? We can discuss that later. And the third thing here that we really want to track is that for the data types and data type for sure. And it's not called a schema, right? The thing here that's in Iceberg, the thing here that's it's very good at handling the schema evolution. Imagine that you add a column or update a column, or probably just change the data type, right? It's actually it actually triggers a schema evolution. It's called a schema evolution. So in essentially, you really want to understand what a schema you have at the moment, right? Because it will have you to inform your query engine, like, well, this schema has already been updated, and you actually have to update that. So that's something that's something definitely we also want to track. And definitely there are some other things like properties, right? And we could keep that part, yeah.
So I have another question. So does it ship with a embedded Spark inside of it to do compaction?
Oh yeah. So this one, so for Nimtable, yes. For the right now, it's it actually leverages the embedded Spark. But so let's go back to this file, right? So optimize table. Let's see that will, if you click this, well, then it will trigger the basically the what is called for the embedded Spark. Basically, we embedded Spark for you, right? But it's just a run, because anyways you have to deploy Nimtable, right? When in a Docker or probably in somewhere, right? And the thing here that's why it will actually support it has the embedded Spark. So if your file is small enough, let's say 64 megabytes, well, yeah, you can use the offer, right? So to use an embedded Spark inside of Docker file. But if you believe that, okay, look, I have a huge amount of data, terabytes of data, for sure you probably have to run a dedicated Spark, right? That's
can I bring my own Spark? can I bring my own infrastructure and connect that to Nimtable and
Oh
have
yeah, that's
Nimtable
a very
take
good
advantage
question.
of?
So
Yeah.
right now I think no, but that's definitely on a roadmap. I think it's
Okay.
let's go back to the GitHub repo. I think it's on the roadmap. Okay. Yeah. Okay. So, but anyways, I think it's definitely we're working on that. Yeah, because we already mentioned the data query engine integration, right? Well, yeah, so basically in the future, you will see a button in the Nimtable that can directly connect to your StarRocks cluster. So somewhere here. So basically, you can also connect your let's say the EMR, probably whatever Spark you have to the file to do the compaction. Yeah.
Yeah, that's really cool. I think that's of probably the biggest challenge when we see in the field is like how do I maintain my iceberg table, right?
Yeah, definitely.
Okay, we have a question specifically for this, so we can do that now. Maybe I missed it. For compaction, huge amount of data. Is compaction scheduling done by a single process or distributed?
Okay, I saw the
Compaction
question.
scheduling.
So basically, if you have, let's say you don't really have a lot of data, right? Well, look, the thing here that for streaming data, let's say that you use RisingWave to ingest the data from your CDC, Postgres CDC, MongoDB CDC, MySQL CDC, whatever CDC, right? For SQL Server CDC into Iceberg. The challenge typically is that we actually have to compact the basically the real-time data, right? So basically, the recent data you have to compact it, right? Well, but for historical data, you probably do not really. They have already been compacted. You do not need to test them again, right? So for this kind of use cases, inside of RisingWave, forget about Nimtable. Inside of RisingWave, we actually do the compaction for you to compact your iceberg table. Seriously, we do a compaction for you, but for in general, forget about the RisingWave context. If you just think about the bigger, let's say, iceberg context or the broader iceberg context, my recommendation is that for recent data, you could probably use embedded Spark, could probably use some small systems to do a compaction. But if you really want to do, let's say, to compact the entire iceberg table, then yeah, you probably have to use some distributed systems.
Yeah. I think his question is more on the scheduling side, or is the compaction side. Just compaction, actually, the computation side. If you can elaborate a little more.
So compaction, right? Well, compaction is more about scattering, to be honest. Well, it's not about for the the execution. Yeah.
Okay.
Yeah, but execution definitely.
I mean, the execution is actually like moving files around, and right. That's what I was talking about.
Yeah, one thing I want to basically it's like ongoing work. So yeah, it's a lot of fun to join this webinar. So you know what? Why actually? Yeah, so I probably have to share a lot of like ongoing works. So you can see my screen, right?
Yeah.
There is actually a repository called Bergloom. I don't know why it is called that like that. It's not the project is not created by me. Okay, to be honest, I can be very transparent. It's not created by me. And the project is about a high performance iceberg table compaction runtime built on Rust. I have no idea about why everyone is like so crazy about iceberg, but essentially, some big companies have really reached out to me. I'm serious. Some big companies have reached out to me to collaborate on this project because they all, yeah, nobody really want like Spark except for Databricks. So yeah, but yeah, actually some big companies reach out to me and say that's okay, let's work on this together because we really want to have a Rust-based compaction system. And essentially that's why people are that's why this project exists. I think right now I don't really okay, so they do have the roadmap. Okay, there are some roadmap here, but so what I can tell you is that for the RisingWave have already used this project to do the compaction, so it does work. But definitely, I also have to admit that there are a lot of ongoing works to be done, and I hope that's what we can deliver that probably later this year. Yeah, hopefully this quarter. Yeah.
Okay, so now let's get all of the Nimtable questions out of the way.
Yeah,
So next one, yeah, why in Java not Rust? I think that's the answer, right? This one's in
for
Rust.
the front end, yeah. So look, for front end we just write code. So for
okay.
front end, I just so look, it's not just purely using some AI agents tools. Well, but what I did to use Visual to do the wireframe thing. So, but essentially we do have humans to work on to do a coding, because for front end you can still rely on, but that's why AI agent actually have a lot of hallucination. But essentially, we for the compaction, specifically for the compaction, we are working on the Java Rust-based compaction, and for Java it's not, it's not efficient. So that's why we are working on Java-based compaction.
Next question: How do you read the metadata from Iceberg tables efficiently to get insights? For Nimtable, our metadata itself is 100 gigs for some tables.
Yeah. Okay. Yeah. So basically, the question is that's where the metadata is big, right?
Yeah. So like how does Nimtable read the Iceberg table? All of the metrics you guys collect, right? How do you guys read
right now I think we usually still relies on the I didn't really write the code, okay, but I guess it actually uses Spark, embedded Spark to do that. But so but I know that yes, in some cases the metadata file is huge, right? Well, like some people say that okay, my data is small, but my metadata is huge. There's some limitation.
Yeah, compactor data expires that helps. But are there any roadmaps to so that process you can probably in the future do that with the distributed Spark cluster as well?
For that, for sure, I think we're definitely that's something seriously we're investing in, right? Well, because that's a huge pinpoint.
Yeah, next one. I see many systems. That's from the follow-up from the other question, the single process.
I have seen a bunch of systems. A lot of I don't know 5.
Yeah, 10. See, many systems usually do compaction scheduling and executed by many workers. Workers can be scaled out, but scheduling usually done by a master node. The master node could be struggling. If RisingWave do the compaction doing the sync, usually the sync operator needs to allocate more resources. Do we design specific algorithms to reduce resource fragmentation at each worker?
Okay, so this question is not about the Nimtable, right? So it's more about the RisingWave itself. So look, we do compaction. Yes, you are right. So because if you do distributed compaction, you actually have it's basically a distributed system. For every single distributed system, the pain point is that we actually have one single. How to say? It's calling a single point of failure, right? So basically, you have to have a metadata node, right? And essentially, and the RisingWave can do, let's say, ingestion. So let me switch to RisingWave repository. It's okay. Never mind. Let me share this tab instead. So for in RisingWave's case, so we actually do the ingestion, we do a processing, we also do delivery, right? We also do serving, and we also do a compaction, right? So we do so many things, and it's not built by one day, right? In one day, right? So we built it for 5 years, and it's running great in lots of use cases. Well, so the challenge here, that's really definitely the challenge is more about the workload isolation. So we actually in RisingWave you could actually ping your node to certain CPUs or to certain nodes, so that you do not affect the other nodes. So that's our solution. I think 4 or 5 years ago when we started, we found that the design was like, okay, let's just have everything competing the same CPU resources, right?
Yeah.
But we soon find that, I mean, for small companies, well, that's fine. But for bigger serious workloads, then definitely it's definitely a pain point, and that's why we developed the workload isolation feature, and which helps a lot of like enterprises if they have a lot of let's say teams, right, for sharing and RisingWave clusters. Definitely they have to do this workload isolation. Yeah.
Fantastic. Next one, I believe StarRocks has a solution to handle massive metadata. Yes, StarRocks does. We are able to read metadata in manifest files
Yeah.
distributively with our backend. So basically MPP that stuff, right?
Yeah.
Not with a single process, not with a single node, but utilize the entire cluster, to read all of your metadata files. So basically, be able to scale, right? But that's basically, yeah, that works to some extent, but it's still a workaround. If you don't compact your table at all and you try to do real time, you try to do like really short interval ingests, right? Micro batches, and that can still cause problems. So okay, next question, can you give some tips on compacting or optimizing the metadata layer?
Compaction.
Check out Nimtable, I think, first.
Yeah. First of all, I mean, so yeah, basically asking about optimizing the metadata layer. So, look, what the thing here that I probably can mention a little bit. So that is, well, you actually probably have a lot of like snapshots, right? And that's one of the reasons you actually have a lot of like big metadata, right? So if you do not really need so many snapshots, then probably you can actually visualize the snapshot trend, right? And you probably could edit optimize this part. I think that's probably one of the things you could do, right? Because for anyways, we have a lot of versions, right? Definitely you will have a much could have a huge metadata.
Yeah, that makes sense. So yeah, retire snapshots and rewrite your data files, right? Compact your data files, do minor compactions on your delete files, right? And also, do metadata rewrites, right? Those all helps, with the sizes and those compounds, because like too many files you have, the metadata explodes, right? So do one thing can help like all of them. So do all of that, and also having the right metric, I think, is probably the most difficult thing, one of the most difficult thing, that we see in the field, right? So which table to optimize and when to optimize and how to allocate, the resources correctly. So that's when you turn to something that's open source, that's Nimtable, or you turn into, a managed solution such as, RisingWave. So okay, that's great. That's all of the question for this, and I think now we can jump back to the challenges and solutions.
Sure.
Yeah. So yeah, now let's talk a little bit about the solutions. So basically, RisingWave. Can you give an introduction of RisingWave and how RisingWave basically solve all of the small file challenges and how the batch commit versus those challenges?
Yeah. So look, well, the thing here that's why I want. Well, we want to talk about is more about RisingWave instead of. But when Nimtable is more about our the other offering, which will be launched probably later this month or probably next. I hope that it's this month. But for RisingWave, it's always the main product. RisingWave is the distributed SQL streaming database, right? So best in class stream processing, management, and analytics. I see some people in the chat that ask me about, okay, what's the performance look like compared to Spark or Flink or whatever, right? So I mean, we outperform any other stream processing systems in two ways. Well, the first one is ease of use, right? Basically, we are Postgres compatible, and we have integrations with all the Postgres ecosystem instead of your random ecosystem, right? And that's number one. And the number two is that, and we have direct integration with StarRocks. We have integration with Iceberg, right? Whatever system you want. So that's number one, right? So you can also even use dbeaver if you are from database world, right? I think for StarRocks, well, they also like I think they can also connect to dbeaver, right, for sure. So you can use all these kind of things, well, dbt, dbeaver, whatever, to manage your pipeline, to manage your whatever thing, right? And second thing here, that's why it's more about the cost efficiency. And we so first of all, in terms of the cost, right? Well, in terms of the cost, we are S3 based. So it could be misleading, but well, we store data in S3, so that's why it could be way cheaper than any other systems, right? Well, but in terms of performance, people will say, okay, if you store everything in S3, it could be like, okay, super slow. That's not the case, because for RisingWave actually offers actually a 10 to 100 millisecond latency. If it's not single digit, well, actually you can achieve single digit millisecond latency through some optimizations. But out of the box, you can achieve 10 to 100 millisecond. I think that's comfort zone. For example, if you do sports betting, if you do the trading, if you do arbitrage, right? So if you do market making, if you do a lot of things, right? Well, performance monitoring, all these kind of things, you do need to have such kind of extra low latency, and RisingWave is very good at that. And apart from that, well, the RisingWave is also very good at doing the incremental computation. Like if you say, okay, I don't really care about the extra low latency, but I just want to do the computation incrementally, right? Because, well, definitely you don't really want to redo everything from scratch, right? You just do incremental computation, and RisingWave is the right answer for you. And it just not just does the incremental computation, but also have they can deliver the data directly without Kafka, right? Or without Kafka Connect or whatever system, it can directly deliver the result into, let's say, StarRocks can deliver the result into, let's say, Iceberg, right?
It's interesting. I mean, talk about stream processing. There's actually a question in the audience we can answer right now. So, what are the advantages between RisingWave versus Kafka plus Flink? Or
Kafka plus Flink, well, I think it's too complicated. Well, the first one, I mean, if you compare RisingWave versus Kafka, right? Well, Flink, right? Well, that's the I mean, that's more about the cost efficiency. That's more about the performance, right? But if you compare RisingWave versus let me share my screen, just one single diagram. So if you compare RisingWave versus Kafka, right? So in the Kafka world, what you want to do is that, okay, you actually have to basically stitch the stream processing with Kafka, with Flink, probably with Kafka, right? Or probably you can switch from Flink to let's say Spark streaming. But you actually have to manage everything, and you also need to manage a database, right? Well, because it's a material, right? Well, because Flink doesn't really store data, right? You actually have to find somewhere to store data, right? But in RisingWave's case, where everything is materialized you, and the different thing here from your let's say, I don't know, Redshift materialized you, whatever materialized you is, as well as all consistency, and it's all and it actually can serve a point access, very highly concurrent point access, very efficiently. You can imagine it like something like Redis or something like I don't know, MongoDB, whatever.
That's really cool. Thank you. And there's another question for RisingWave. So it's just here. Besides streaming Iceberg challenges, others, these streaming, with the challenge we talk about, there are others, OMs of stream processing, because memory utilization on networking, heap, non-heap, is highly dependent on the data source, event data point size, which is unpredictable. And second, how to deal with large volumes of states. We'd love to hear how RisingWave handle these challenges in different ways compared to Flink.
Well, for handling large states, well, that's actually a huge win in RisingWave, because we actually have you do not need to manage your states, right? So you do not need to worry about your RocksDB, right? because I know that's why in Flink, if you talk about Flink, right, they use RocksDB, and you know that RocksDB really sucks, right, in terms of log state management cases. But RisingWave actually stores the states in S3, actually persists the stores in S3, and caches the states in memory, right? Well, so it's actually basically a disk. So you have the persistent storage, and you have the cache in memory. So in this way, we can definitely handle large states, right? So you do not need to worry about, whether my system will crash because of the other memory. Yeah, if you do not really provision enough resources, definitely it will crash. But the challenge here in Flink is that even if you provision enough resources, you can still crash, because you have to maintain huge states in memory, and it's not very efficient at all. But in RisingWave's case, everything is the state is managed in S3. So for the heap, non-heap, whatever networking, memory utilization, right? Well, it's more like a Java. I think it's more like a Java-based concept. We are not in Java, we are in Rust. So you can always trust Rust, right? Yeah.
Yeah, that is true.
Yeah. Some people will tell me that they like a crypto fintech or trading, right? Well, they will tell me that they do not really accept any JVM based systems. That's why they switched to RisingWave.
Yeah. Okay, so let's go back to the slides, and this is RisingWave, and quick little rundown of StarRocks. StarRocks is a query engine that works on top of open Lakehouse format like Apache Iceberg, right? Linux Foundation, Apache license. It's really good at doing low latency on Apache Iceberg, right? It does all of the crazy optimizations for Apache Iceberg. So for those like real time customer facing like use cases, right? Distributed metadata scan that we just talked about, right? If your metadata is too big because you don't compact the table correctly, or just have too much data, you can actually parallel read the metadata, not only the data, but all of the metadata files. And metadata cache, make sure the planning is always fast, right? SIMD, so execution engine built in C++. So we're able to scan, join, and aggregate all of the operators. Do that all with SIMD, right? So do that in micro batches. For OLAP, the more batch you run, the faster kind of it's gonna go, right? So optimal performance for low latency kind of workload, right? And also some more detailed optimization, such as optimize equality delete handling. How do we you can use equality delete, right, to get better data freshness. And we're able to also make sure the query runs as fast, right? So basically run customer facing analytics directly on your Iceberg tables. So this is StarRocks and RisingWave. So this is the kind of like a reference architecture, you can use when you are trying to build your streaming architecture, streaming pipeline on top of based on Apache Iceberg. This I think is actually all we have. So try out RisingWave Cloud, try Metadata Cloud, and join the both Slack channels. If you're into Iceberg, if you're into stream processing, you're interested in real-time analytics, customer-facing analytics, definitely join those channels. And also be sure to check out Nimtable, right? So you can manage, compact your Iceberg tables correctly and more easily, right? Any more questions? Gonna give a few more minutes for questions.
Why
this might not be relevant, but why only support Iceberg? Why not other more known formats like Pymon or Hoodie?
That's a tough question. We would love to support everything, but we started with Iceberg and then Delta. I think StarRocks and both StarRocks and RisingWave support Delta. So actually there are some announcement next week in Databricks, the Data Plus AI Summit. We are actually I mean, Databricks will launch something new, keep an eye on that. Could not do. Sorry about that.
Let's see if there are any other questions we left out. If we left out your question, please ping in the chat. Let's give it a few more seconds. Any more questions? Let me scroll through everything and again, make sure we have everything. Okay, nice. I think that's all of the questions that we have. Thank you everyone so much for joining us today. And thank you, Ingjun, for giving this wonderful discussion with me. Thank you. Appreciate that. Thank you.
Thank you. Yeah.
Thank you. Bye. Thanks.
Bye.
See you guys again next time. Thanks.
See you.